who will tell us about something I've wondered about for a long time now, and that is these contests, these programming contests. What are they like? I would be afraid to enter any, but obviously with enough practice, one can become an expert at participating in contests. And so this is a contest called Xtreme, which I hope we will all learn something about, because I'm eager to know.
And that's a good point. Is you don't have to practice to be good at them. They are the practice to improve your coding skills. At least I see it that way. And no promise that I'm a super good coder or anything, or a good presenter, but I will try my best and hopefully make it interesting for you all.
Could you use the microphone? It'll make it,
right.
The recording.
Can you hear me now?
Yeah, the recording
okay.
will be clearer.
Forgot I had this. So, IEEE Extreme is a global programming competition put on by IEEE annually for student members. And you have 24 hours to complete as many problems that they give you, and you're ranked amongst everyone else who competes worldwide. And you can either tackle these problems solo or team up to 3. And it's held in October, so we just had a competition. It was October last month. Time's flying by. And it was on the 19th. It was on Friday and went through a Saturday for 24 hours. This was the 13th IEEE Extreme. So it started in 2006, and it's been going on strong. I've competed in the last 2, and I'll talk to you about how the competition is formatted so y'all can know that, and then I'll actually talk about some actual problems. So we have a variety of students that come in and compete. We all are in the same area, and it's kind of a social event in that way as well, where we have food. And we actually have students from Kentucky State that have been with us the last 2 years. They may have been there before as well, but I've only been involved the last 2 years. And we go to the 4th floor of FPAT, just on campus, and you're there for 24 hours. You don't have to stay the full 24 hours, and not all programming competitions are like that. Yeah, usually it's not that long, and you only have a few problems. I know ACM puts on a lot, or they partake in competitions regularly. So if you're more interested, you can start with one of those. IEEE Extreme, I think, a good one, and you don't have to stay the 24 hours, and stay just an hour if you want. You can come in one day, go sleep, come back, whatever you want. And the actual competition is hosted online on a site called CS Academy. They partner with IEEE to host the competition, and they have a programming environment online where you can see your problem and have a section of code, and you have standard input, output. And they support 29 languages total. I did all of my problems in C++, Python 3, just because that's what I'm comfortable with right now. But you can, a lot of problems you'll see different programming languages are tailored to different problems. Just like in the real world, you don't always use the same language for the same problem. So on the left here is a trimmed version of the web page where all the problems are. There's a little ellipses there. So you start at the bottom and they give you a welcome message, and then start you off with 2 problems. And then they give you like 24 or more to go on for the 24 hours, and they release them hourly usually. And you get scored. This is how they rank. So each problem you can get a certain number of points for, and there's test cases, so they usually give you some examples, and you try to give your solution to the problem problem, and then you submit it, and they run through test cases that are trying to break your code, and the circle here shows you what percentage of those test cases you got correct, and then you can get up to a maximum number of points for each problem. That will go down as more people complete it. So the more people that complete a problem, it's worth. So that kind of weights it in a way that the harder problems become worth more points. So here's what the actual programming interface looks like. You can collapse either side and move it around. On the left will be your problem, and this standard input-output will give you some examples. On the right, you'll put your actual code, and there's input and output tab. That's just for the standard input and output. You can put whatever you want in the standard input, and it'll come out in the standard output through your code. And then once you think you have a good solution, you can hit that red submit button on the bottom right, and it'll run through all the test cases and tell you if you got any points.
Can you resubmit to get it better?
Yes, you can. I think they have some rules on it where it's you can't submit the same code twice within 1 hour, and some checks like that. But yes, you can edit it as much as you want. You don't have any limit on your attempts. So here's an I/O example. So there was a problem called lexical addition, where essentially you're given, the problem will tell you what you're given. You're given N, A, and B, where you're looking for some set of X's between A and B that can add up to N. And you output either yes or no, if it can or can't, and then the sequence of those X's. And each problem is different on its input and output. Most of them are like this, where it's like a standard input output, just standard text. There's a few every year, like one every year, that's more of a graphical interface with the input and output, but I won't get into those, but they're kind of interesting. And it gives you some constraints about how large their test cases variables can be. So you gotta think about what data types to use, probably use a long instead of an int, which I always forget to do. So now that you kind of know how it's formatted, and show you the actual content. So just like life, I have a lot of problems to show you and a few solutions, and they're my solutions, so they aren't that good of solutions. But we shall see. So this problem is called extreme wrappers. You can just ignore the code for now. I'll try and explain the problem to you. You have two people that have a dictionary of words, and their vocabulary is K words or J words, respectively, and you're looking for the maximum number of 3-word sentences, basically, they can make. And they're distinct, unique words, and once you use a word, you can't use it again, so it's a limited supply. And my solution was to just, you go, I programmed in Python 3, and they give you some helper functions at the beginning, just so you can interact with the standard in and out. In C++, it's just C in, C out. In Python 3, it's a little trickier, so they give you the helper functions. But you can kind of ignore that for now. So this is the actual code I wrote, so it was quick. And I tend to always comment my code, even in speedy competition.
Good for you.
Which I think is a good habit. So it's not too much. You get your input, and you see if you can make any combinations. If you can, you find the largest one, take 2 from it, and the smaller set, you take 1 from it, and that's 1 sentence. And it's kind of inefficient, and you don't really realize that while you're programming it until later, but then you're moving on to the next one. So I got 59% of the test cases right using that code. I got some points with that. And then this is the code from our IEEE president, Jaron Tay. He was going to come today, but he's feeling a bit under the weather, so I'll show his code some. Basically, he does a similar thing, but instead of looping through and minusing 2 and minusing 1, he just has an equation to figure out. So much more efficient than what I did. And he got 100% of the test cases right. This was an interesting problem. I'm sure many of you are familiar with the traveling salesman problem, and this was kind of like that on steroids, where you have a bunch of salesmen. Salespeople.
Sellers.
Yeah. Gotta be politically correct. So basically, you have you're given, the first is n for the number of pounds, and then the next line is n numbers with the price of a good at each town, and each town carry the same good, and you're looking to have each seller buy from one town and sell to another town without crossing paths with another seller, so as not to create competition within the merchant association. And then after the prices is the map of roads connecting towns. And then at the bottom you have 5 salespeople and the starting town for each of them. And this was a it looked like a very tough problem to me at the time, so I didn't actually make a solution for this, but I thought it was interesting just because it was familiar as a traveling salesman problem. And this is an example where it shows you a solution to the problem, and your maximum profit can be 12. So all of the 4 salesmen go and buy from one town to another, and then merchant 12 doesn't travel at all because he can't make a profit without interfering with where the other merchants have already been. This one's minimum permutation, and this was the best I did this competition. I actually got 100% of the tests correct. And basically you're given 2 numbers first, n and m, and then you're given n numbers for an array of A and m numbers for S, and you're basically going to try to put all the elements of S into A. You're going to insert it in there so that it's lexicographically the smallest, so like a dictionary, it would appear first in the dictionary. And I used that kind of thinking to help me think through it, where we're given numbers, but I thought of them as letters, and we have a lot of whiteboards when we're working on these things, and as night goes on, they'll get more and more full. So, like for this example, say you're given A is those numbers, which equates to cat, and S equates to bud, and you put B in. A doesn't move, you just insert letters of S in the order that they should appear. So B is before C, so it goes there, and just like the dictionary. And my code basically does just that. It takes in the A as a vector. I did this one in C++, and takes in S. It sorts S, so I know which element I should be working on first, just in that order, and then I iterate through A and have the element that I want to put in, and I see where it goes in. Do you have a question?
Yeah, so instead of like sorting S and then inserting that, never mind. Okay.
Yeah, the code may not be, actually I can almost guarantee you it's not best. That happens when it is a competition and you try and go through quickly, and there's almost no way to actually complete every problem on time. So I do try and take my time, but I do also try to go a little fast to, just improve my speed. Yeah, so that one works like that, where I did do one thing kind of smart, where I didn't go at the start of A every time. Because if I have S sorted, the next element will be after the first element, and each of the elements was guaranteed to be different numbers, so it's not like you get 2 1s or 2 2s or whatever. And then I print A, and that's the output. This was Jaren's code. I think he did a pretty similar thing he was going to talk about, but he's not here. So we shall move on. And then this one was an interesting problem. It's called puzzle of rooks. So chess, there's rooks. They can move down, left, and right infinitely in that direction on their move. And what you have for this problem is you're given rooks and their starting position and their ending position. So they want to get to the ending position, but you do not want them to be in like check with each other if they were kings. So you don't want them to be able to attack each other. So this one, you could just move them over, like swap them over to their right spot, but in that process you'd be putting them in the same column.
Where's the suggested ending position?
Oh, so let's say you have this red one starts where the actual rook is, and the ending position is the colored square. So the way that the problem lets you get around this is you can pick up one rook at a time, hold it, and then move any other rooks, and then put that rook back down, and you then pick up another rook. And you have to pick it up and put it back down in the same spot. So what you can do is you can pick up the red one, move the blue out of the way, put the red one back down, and then move the red one to its final position, and the blue follows. And so it seems pretty straightforward enough when you just have two. But the problem is the board can be infinitely big, have very large test cases, and you can get something like this where you need to go white rooks to the black rooks. And my partner that I was working on the code on the competition spent a lot of his time on this. He wrote over 200 lines of C++ code, and he got 0% of the tests right. So there's a lesson to learn from this. Don't waste your time on something that you have no chance at beating. That might be kind of pessimistic. Let me reword that. If you feel your talents can be better utilized going forward with some other problem, it might be a best course of action to pursue that instead of banging your head against the wall on one problem.
This particular problem doesn't look like it's solvable.
Yeah.
No matter what you pick up,
Well,
you put it back down in the same place. Whatever you move will certainly
right. It's all standard input, standard output, so it's kind of hard to show graphically. But the chessboard is technically infinite, so you like yeah. So I'd say move them all off, make like a buffer, and then have like gates where you pick one up and move them through. But it became very complicated.
And it was to find the minimum solution or any solution?
The minimum, I believe. I think it took one solution, but I don't remember exactly. This is my favorite problem. It's from IEEE Xtreme 12 last year, which was my first IEEE Xtreme. And this is all they gave you. They said you have this input and this output. They gave these two examples, and they said, go. And it was my favorite just because of how convoluted and impossible it is. But after the competition, someone actually solved it, and I can share with you that solution. So these inputs, you can see that you have 2 and 3 denoting how many lines you have input, and they may seem like gibberish, but it's actually an obscure language that some guy made up like a few years ago, just one guy. And there's actually a trick to the language, is you can look at like they call it a Rexian. You can look at the letter in a Rexian, and then look at your keyboard where it is, and you can see Y. You go to the left on your keyboard, that's the English letter. So Y turns to T, E turns to W, P turns to O. So that's 2. I don't know how they expected to solve this. One of the Kentucky State teams from last year actually kind of became obsessed with this problem, and they made it to the language. They found the language. They started to learn the language. They didn't make it beyond that, though. But it was interesting. It was like an Easter egg hunt. So then you can take those. Oh, and one thing I should mention is, like, during IEEE Extreme, you have access to the internet, whatever resources you want. It's not like a closed note test. So that's how they could find that. They didn't just know it. So moving on to how you would actually solve it, you take those words, change them to numbers, and they aren't just base 10 numbers, they're hexadecimal numbers. So you have to realize that, and then convert them to base 10 numbers. And then you have to multiply your numbers together. So in this first one, you multiply your 2 input numbers together, and it ends up as 99,999. And for the second one, you multiply these 3 together, and it ends up as that. So here's like a little example. How you would solve the first example is you take the gibberish, you turn it to words, actual words. You turn that to numbers. That's hexadecimal. You convert that to base 10, multiply them together, and 41 times 2,439 is actually 99,999.
It's like a substitution cipher,
Yeah, exactly like a cipher. But yeah, I looked at that problem some, and there was no way to solve it. This is the lexical addition problem from earlier. This is actually Jaren's code. I did not do very well on this problem, so I'm not showing my code. But essentially, if you remember from earlier, you're given n, a, and b, and you're looking for x's that are in the range a to b, and any x's, like it doesn't have to all be the same number or anything, that sum up to n. And you output either yes or no, and if it's no, that's all you output. If it's yes, you then give the lexicographically smallest set. So as an example, it's like, say you're given n equals 59, and then the range 8 to 10, you can add up 5 tens, 9, and that's the lexicographically smallest one. So it would be like the same thing like the dictionary, where 9 is would be before 10 and all that. Yes. So that's all the problems I have for you today, but it's just scratching the problems, and all the problems are available online. You can go to CS Academy. They have a practice community with all the problems online, and you can actually do the same little programming environment that they have during the competition. And you have problems, try them, submit them on the same test cases that were during the competition, see how you do. And then there's also GitHub repos and other places online where people have saved PDFs of the problems, or even have their solutions posted where you can view the approach of others, which I think is, it's good to see a different perspective. That's kind of why I include Jaren's code and my code, at least in this presentation. But there's a lot available, and maybe if you might be able to find like some inspiration for programming assignments for your students or something. Probably don't give them the magic cipher one. These are all the problems from last year and this year. I'm not going to read I'm not going to read all of them, but if you like see one that sticks out to you, you want to know what it, Google it. Do Google IEEE Extreme problem name, and then there's 11 years prior to this, so there's a lot of problems out there. And it is a competition, so here's the results from the last 2 years. Illinois, Urbana-Champaign, the team from there won both times I've competed. I don't think they won the previous years with that, but Jaren's team has done the best out of our UK teams both years, and he's improved himself, improved his ranking through the year. My team has, we did pretty well last year, did okay this year. I think a lot of that was my partner was doing the rooks the whole time this year, and also I was the one planning this whole event, so that added some stress to my my problem solving. Also, I think the last year I went home, got a good night's sleep, came back, and I was like rejuvenated. This year I decided to stay the whole time, and it was tough. Yeah, but I don't think I did too bad this year either. Usually there's about 4,000 teams that actually are competing. About 5,000 teams registered this year, so you don't have to compete after you're registered, but registration opens up, I don't know, I think September, and closes like right before the competition, like the week before the competition, so it's in October. So if you are interested in competition, look for it next October. Or you can, there's definitely other programming competitions out there. I'm not too aware of all of them, but I'm sure people in like ACM or RCS faculty would know. So to conclude my presentation, I'd say students, I encourage you to participate in coding competitions. It's a great way to improve your skills. Maybe you want to learn a new language, and trial by fire isn't that bad. Like we were saying before, a coding competition can be seen more as practice rather than competing for some prize. Oh, and the prize for IEEE Extreme is the winning team gets to go to any IEEE conference in the world that they want to, all expenses. And then professors encourage your students to participate in these fun competitions as well.
Who is eligible to participate?
In IEEE Extreme, it's IEEE members that are students, so that I think the student rate for IEEE is $30, which is not bad. Plus, you get probably well over $30 worth of food, even at just Extreme. But you don't have to participate in this one. There's plenty. Just look around, maybe Google programming competitions, or talk to someone from ACM or someone who knows a little more about all the others. I mean, I know a lot about Extreme. That's what I've been doing, but yeah, thank you.
Are there other questions? Well, yeah.
I want to, have you heard of code golf?
No.
So code golf is a sport in which you try to, for a specific problem, write a piece of code to solve it in a minimum number of bytes. I don't know if there are any competitions for it. There is a sort of Stack Overflow forum set up for it. That's another thing if you want to practice your coding skills.
And coding in a small number of bytes is not necessarily good coding.
No, it is definitely not good coding. In fact, they use a lot of esoteric languages to get those. bites down.
That's interesting.
Other questions?
You call it coding golf?
Code golf, yes. Coding golf. The idea is like it's golf, so you want the smallest score
Right.
possible.
That's interesting.
So I want to thank Dr. Finkel for having run an excellent series of talks this semester.
One idea for next semester is to ask faculty, each faculty member, to present one thing that they have done in the past, which they're particularly proud of. And so it can be 30 years ago, or it can be last week, but hopefully we'll get a lot of good faculty talks, as well as a nice collection of undergraduate talks, we've had some very nice ones, and graduate students as well. So see you next semester. Happy Thanksgiving.